Okay, so the second question, before we get to the second question, I'm just going to show you page 2 of this one. This is just basically a copy of the grade 10, the old grade 10 provincial exam formula sheet. It's a really good summary of the different, I guess, geometric shapes that we come across. So it has like the surface area and volume for cylinders, spheres, cones, square-based pyramids, rectangular prism, and etc. So both equations. So for this the second example we're doing is people who go shopping know that you can buy mini oranges or large oranges. I love oranges, favorite fruit. And we're going to assume that these oranges are perfect spheres. So if we look back up, we say, okay, this equation sphere is surface area is 4 pi r squared, volume is 4 over 3 pi r cubed. And it shows a picture of our sphere right there. So radius from the center to the edge. So the mini orange has a diameter of 5 centimeters. So we can actually draw that in. So we have a mini orange. And to show 3D depth, I'm going to draw an ellipse within to kind of show that depth that it has. And it has a radius of, well, if the diameter is 5, the radius is going to be 2.5 centimeters. This is a large orange, so the diameter of 12 centimeters. So when we talk about radius 1 and radius 2, it's going to be 6.0 centimeters. So there's two ways to solve for this one. We're saying how much more orange do we get with the larger orange? So what we can do is you can solve for the volume for each of them if you want. So you say, okay, look at the previous page. Volume is 4 over 3 pi r cubed. So we have the small one and the big one. So it's going to be r1 cubed. This one's going to be 4 over 3 pi r cubed. So to solve for this, you say, okay, 4 over 3 pi, we're just going to plug in that 2.5 centimeters. And we're going to cube that. For the other one, we're going to plug in that 6 centimeters. And we're going to cube that. And we can get our two volumes. So 2.5 to the power of 3. And we're going to multiply that by pi. And multiply that by 4. And divide it by 3. So we get 65.45 centimeters cubed. So that's the volume of this orange. Now, what does it mean to be a centimeter cube? Well, if you actually measure a cube that has a 1 centimeter by 1 centimeter by 1 centimeter on a side, 1 cm, 1 cm, 1 cm, it's saying that if you have 65.5 of those, that would fit inside one of these oranges. Okay. For the other one, we have, okay, so 6 to the power of 3. And we're going to multiply that by pi, and multiply it by 4, and then divide by 3. We get 904.78 centimeters cubed. So we now divide those two values. That's our k cubed factor. K cubed is equal to 904.78 centimeters cubed divided by 65.45 centimeters cubed. Get a value of, so divide that by 65.45. Get around 13.8. So you get 13.8 more orange. And that's the long way of solving. The quick, easy way of solving is really understanding the k squared, k cubed. So all we have to do for this one is recognize that k is equal to 6 over 2.5. Okay, start with that. So 6 over 2.5. That's 2.4. And now we're just going to cube both sides. Cube it to the power of 3. And guess what? That's equal to 13.8. So you tell me which way is easier. Method 1 or method 2?